Okay, so guys and girls, what I'm going to cover in this topic here is quite a few things actually. We're going to start off with endo and exothermic reactions. So I'm going to write exothermic reaction and I'm going to explain what it is. So an exothermic reaction is anything that is a reaction that gives out heat, that gives out heat energy. Okay, so anything that gets hotter, basically a reaction that gets hotter, that causes an increase in temperature. That's a better way to say it, really. Causes an increase in temperature. Now, let's have a look at an example of what I mean by that exactly. Let's say the reaction starts at 10 degrees C, but by the time you're done with the reaction, it ends up being at 25 degrees C. Right, clearly there is an increase in temperature. So if the temperature has increased, this is an exothermic reaction. So you might be asking, well, what are some examples of an exothermic reaction? There is the classic hydrogen balloon experiment, right, in which you combust or burn hydrogen. So when you combust hydrogen plus your oxygen, right, it releases a lot of heat energy. If you think back to the balloon exploding and making that heat energy. Now, of course, hydrogen plus oxygen makes water, but this is the combustion bit here. It's when you're reacting it with oxygen. Now, other combustion reactions. So this is an example of combustion reactions cause an exothermic reaction. So if you're burning methane with oxygen, that's going to give you your carbon dioxide, CO2 plus water, and basically that is another example of something that's going to give out heat, right? So methane is a gas. You burn the gas in this combustion equation, in this combustion reaction using oxygen, it's going to give out heat. So we've had a look at exothermic reactions. Let's now do endothermic reactions. Okay, so endothermic reactions are reactions in which endothermic reaction in which heat energy is taken in. Heat energy is taken in from the environment. And as a result, because the heat energy is taken in from the environment, then what this means is that the surroundings is going to get cooler. So you will feel a coolness. Okay, so in other words, say more quantitatively, as i.e. in a way that we can understand using numbers, is if the reaction starts at 30 degrees Celsius and it goes to, let's say, 15 degrees Celsius, this is going to feel cooler than what it was at the beginning. And so this is an endothermic reaction because the temperature has gone down. Endothermic reaction. So now you might be thinking once again, well, give us an example of an endothermic reaction. And a classic example is photosynthesis. Photosynthesis, because of course photosynthesis uses the sunlight's heat energy, so it's taking in the heat from the surroundings, and it's going to use that for the process of photosynthesis. Now, just to remind you, a quick equation for photosynthesis is your carbon dioxide plus your water makes your glucose plus oxygen. Okay, so this is not a balanced equation. You don't need to know this equation. All you need to know is, like in the word equation, is carbon dioxide plus water makes glucose plus your oxygen. Okay, you don't need to know the chemical formula. So photosynthesis is an example of an endothermic reaction. Okay, so anything that's going to cause the temperature to go down is an endothermic reaction. Anything that's going to cause the temperature to go up is an exothermic reaction. Now here, what I want to show you, once I get rid of this, is the bar magnets that I've drawn, because you need to be able to explain whether the process of breaking bonds is exothermic or endothermic. Okay, so this is my analogy that I use. Okay, here we've got a south bar and a north bar magnet, and they've joined together. This is representing, it's a representation of my bonds in my chemical. So this is my chemical bonds. Now the question is, if you want to separate those two magnets, are you going to put energy in to break the bonds, or is the bond going to let energy out to break it? Well, if you think about it, you need to physically, with your hand, remove these bar magnets, right? You need to physically remove it with your hand. So that means you are putting energy in to this in order to break the bonds. So what we can say then is, if you're to break bonds in a reaction, right, we need to put energy in. Now if we're putting energy in, this means it's an endothermic reaction, because remember, putting in energy into a reaction is going to be endothermic. Now the question is, now that we've put the energy in and we've broken the bond, and we know that breaking bonds is now an endothermic process, what if we have bond formation? The question is, what about bond formation? So here's my south magnet, here's my north magnet. I'm just going to draw these two poles because it just makes it easier. Now the question is, forming bonds, so the bond hasn't been made yet. The question is, forming bonds or making bonds, is it an endothermic process or an exothermic process? Now the way I demonstrate this in my class is, I let these two magnets go and they end up joining together. But what you'll hear is, once they join together, so here, and where's the red? Here it is. So once they actually join together, you'll hear a sound being released. Okay, now sound is a type of energy. So once they join together, sound energy is released. So if you think about it, sound energy is out. Now this is an analogy, okay, just to kind of help you understand. So bond formation or making bonds is going to be an exothermic reaction, because energy is released, more energy is released in the process. So it's exothermic because more energy is released than is taken in. Exothermic process because the energy is coming out more than it is going in. So that's brilliant. So I'm going to stop there. That is exo and endothermic reactions done. Next I'm going to be doing, well, you'll see.